This is Bob Capetta of the University of Illinois at Chicago, and this lesson is on solving exponential equations. First example, 2 to the x plus 1 equals 32. And with a problem like this, we recognize that 32 is also a multiple of 2. It's 2 to some power. We're going to try to use that fact to enable us to solve this. So we have 32 is 2 times 2 is 4, 8, 16, 32. 32 is 2 to the 5th power. So we'll replace 32 with 2 to the 5th power. So we get 2 to the x plus 1 equals 2 to the 5. So if that's the case, x plus 1 has to equal 5. Subtracting 1 from both sides, we get x equals 4. But what enabled us to do that was recognizing that 32 was 2 to some power. Our next example is 2 to the x plus 1 equals 1 over 128. Same sort of thing happens here. What is 128? 2, 4, 8, 16, 32, 64, 128. It is 2 to the 7th power. So 2 to the x plus 1 is 1 over 2 to the 7th power. We've got to remember that 1 over 2 to the 7 is the same as 2 to the negative 7 power. So at this point we have 2 to the x plus 1 is 2 to the negative 7, which would mean, of course, that x plus 1 would have to equal negative 7. Subtracting 1 from both sides, and we get x is negative 8 there. Now, the next example requires a little bit of a twist. We have 9 to the 2x plus 1 is 27 to the x. Now, 27 is not a multiple of 9. 9 to the first is 9. 9 to the second is 81. But they are both multiples of 3. 9 is 3 times 3. 27 is 3 times 3 times 3. That is what's going to enable us to solve this problem. So let's recognize that fact. 9 is 3 to the 2nd power. 27 is 3 to the 3rd power. So we're going to rewrite 9 as 3 to the 2nd power raised to the 2x plus 1. Rewrite 27 as 3 to the 3rd power raised to the x. And then we must remember that when you raise a power to a power, you multiply the exponents. So on the left-hand side, it will be 3 to the 2 times quantity 2x plus 1. On the right side, it will be 3 to the 3x. Now, if that's the case, 3 to that exponent equals 3 to that exponent, we know this exponent has to equal that exponent, or 2 times quantity 2x plus 1 has to equal 3x. And now we're just doing basic algebra. Distribute. 2 times 2x is 4x. 2 times 1 is 2. 4x plus 2 is 3x. Then what do? We subtracted 3x from both sides, or so it appears. So that would be x plus 2 equals 0. And then subtract 2 from both sides, and we get x is negative 2 for that problem. But the key was to recognize 9 and 27 have a common base. The common base for 9 and 27 is 3. But when I get a problem like this, 5 to the x equals 7, there is no common base for us to work with. So the tool we have to use here is a logarithm. We'll take a logarithm of both sides and then solve the problem that way. I prefer to use a natural logarithm. Of course, you could take log base 5. That would also be an efficient way to solve this problem. But I'm going to take a natural logarithm of both sides. Natural log of 5 to the x equals natural log of 7. The x comes down front. We can pull that exponent down. So we'll say x log 5 equals log 7. Next up, we're going to divide both sides by log 5. Dividing both sides by log 5, you can see that we get x is natural log 7 over natural log 5, which is the same as log base 5 of 7 using our change of base theorem. But again, I prefer to use natural logs because we have that built in on calculators and other sorts of places. Our next example is 2 to the 3x plus 1 equals 11 to the x. There is no common base here for us to work off of. So we're going to go ahead and take a natural log of both sides again. So natural log of 2 to the 3x plus 1 equals natural log of 11 to the x. And we want to pull the exponents down, but before I do that, I want to emphasize the fact that that exponent is in parentheses. So when I pull the 3x plus 1 down, I want to pull that 3x plus 1 down in parentheses so that I can distribute properly. Same thing on the right side, log 11 to the x, we pull the x down front and it's x times the natural log of 11. Once we're here, we have to distribute. 3x times log 2 is 3x log 2 plus 1 times log 2 is 1 log 2 or log 2. So you can see I have 3x natural log 2 plus 1 log 2 equals x log 11. And our goal is to solve for x. So we need to get all the x's on one side, all the numbers on the other. So let's identify that process. And so here's where we are. And I'm choosing to subtract 3x log 2 from both sides. That will eliminate the x's from the left side, and all of the x's will be on the right side. What is left on the left side? Just 11 log 2. What is left on the right side? X natural log 11 minus 3x log 2. At this point, you can see we have an x in both spots. We will factor out the x. So the left-hand side is log 2. The right-hand side will be x times quantity, natural log 11, minus 3 log 2 when I factor that x out. And then the last thing we have to do is divide by what's multiplying x. So divide both sides by natural log 11 minus 3 log 2. And we get our answer that x is natural log 2 divided by natural log 11 minus 3 log 2. So when you don't have common basis to work with, it is best to apply a logarithm to both sides. I prefer to use a natural log. Our next example is 3 to the 2 minus 5x equals 8 to the x plus 1. If it were a 2, we could have a common base, but there is no common base here, so we're going to have to use a natural log. Hit both sides with a natural log. Natural log 3 to the 2 minus 5x equals natural log x plus 1. I want to pull the exponents down using our property of logarithms, but I want to make sure we recognize that the exponent is in parentheses. So I'm going to rewrite 2 minus 5x as 3 to the parentheses 2 minus 5x, rewrite x plus 1, 8 to the parentheses x plus 1. Now when I pull down the exponents using our rule of logarithms, we are then ready to distribute. So let's think about this carefully. 2 times the natural log of 3 minus 5x times the natural log of 3 equals x times the natural log of 8 plus 1 times the natural log of 8. And our goal is to solve for x. So I want to get all of the x's on one side. I want to get all of the numbers on one side. Factor and divide. So we need to think about how are we going to get all of the x's on one side of this equation, all of the numbers on the other. So here's where we are. And what I'm doing here is I'm adding 5x log 3 to both sides. That will cancel the negative 5x log 3 here and leave me with x log 8 plus 5x log 3 on the right side. So both sides of the equation, I add 5x log 3 to get all of the x on the right side. But if I'm having all of the x's on the right side, I have to eliminate this natural log of 8. So I'm subtracting natural log of 8 from both sides here. So what's left on the left side? 2 natural log 3 minus natural log 8 equals x natural log 8 plus 5x natural log 3. So we have successfully isolated the x on the right side. But I still have these numbers, so I'm going to factor the x out. Factoring the x out on the right side, that will leave me natural log of 8 plus 5 times natural log of 3. And then to solve for x, what do we have to do? Divide both sides by the natural log 8 plus 5 natural log 3. And there's a result. 2 natural log 3 minus natural log 8 over natural log 8 plus 5 times the natural log of 3. Challenging question, a lot of algebra, a lot of moving parts. But if you do it properly, there's no reason you can't do it correctly. Okay, our next example is going to be 4e to the 3x plus 2 equals 13. So we just want to have an exponential equals something. So my first move is going to be eliminate that 2. So we'll subtract 2 from both sides. And that gives me 4e to the 3x equals 11. And I want to get the exponential by itself, so I'll divide by 4 to say e to the 3x is 11 over 4. The next move is to take the natural logarithm of both sides. So the natural log of e to the 3x equals the natural log of 11/4. That's how we'll be able to move the 3x down from the exponent. So I can pull the 3x down. It'll be 3x log e. And remember, the log of the quotient is the difference of the logs. So just to make this a little easier to write, for the natural log of 11/4, I'm going to think of it as natural log 11 minus natural log 4 using our rule of logarithms. So the 3x coming down front, 3x times the natural log of e equals natural log 11 minus natural log 4. Natural log e is just 1, so we'll say 3x is natural log 11 times 1 minus natural log 11 minus natural log 4, or 3x equals natural log 11 minus natural log 4. To solve this, we will divide both sides by 3. What will that look like? X is natural log 11 minus natural log 4 all over 3. And that will conclude this lesson.